Macquarie Harbour is a large and unique system to work in. Few people would realise its sheer size. It's 6 times the size of Sydney Harbour. It's characterised by a deep central basin and this really narrow sill at the entrance to the ocean, and they're really important characteristics for how we see the harbour behave. It's also got those 2 strong big freshwater inflows from the Gordon River and the King River. The harbour is what we call highly stratified. That means because of those strong freshwater flows, it's got a thick freshwater layer on the top, and then it's got this dense marine seawater underneath. Now what that means for the system is it takes a lot of energy to push oxygen through the freshwater into those deeper layers. That thick freshwater layer that we see on the top is one of the key reasons that it's attractive for growing salmon. Because in other growing areas, amoebic gill disease is a significant cost to the industry because they need to bathe those fish in fresh water to kill that disease. So Macquarie Harbour, because it's got that thick freshwater layer all the time, it's a significant saving in terms of the labour that you need to spend with those fish. It's useful to think about the oxygen levels in the harbour as a balance between supply and demand. The things that we know supply oxygen to the waters are wind, quite clearly. They oxygenate the surface water. But we also know that the ocean water is oxygenated, and when that can come over from the sill, that brings oxygen with it, and because it's heavier than the fresh water on the top, it sinks down to the bottom, and so that can help oxygenate those bottom waters. So we've got wind, we've got the ocean, and then the river water also brings oxygen with it. On the demand side of the equation, these are the things that consume oxygen. We have things like the organic matter or the plant material that might come down in the catchment. We have growth that happens in the harbour itself. When that breaks down, it consumes oxygen. And of course, then we have fish farm waste. So waste feed and faeces that might hit the bottom, that's also going to consume oxygen. It's quite a unique system because it's got that really dark tannin-rich water that you get from the catchment, because it's quite a pristine catchment, and that tannin comes from button grass and things like that. So what that means is that you don't get much light penetration into the water column, and the algae and things like that grow in the water column need light, so there's not a lot of primary production. So that means naturally for the fauna that live down in the sediments, there's not a lot of food. Macquarie Harbour is naturally depauperate. There's not that many animals, there's not that big a biomass of them. So that means that when we add a source of organic matter from a farm, it's actually quite easy to see it because it's essentially against a fairly blank canvas. That response in terms of the fauna is actually a really important part of sustainable farming. It's like a compost heap. We actually need fauna to respond to the enrichment under a farm. We need fauna to increase in numbers, and we need them to process that organic material. What we don't want though is that waste to be spreading off the lease, and that's why the companies are regulated with compliance points, which are 35 metres from the edge of the lease. And that means that at those 35 metre compliance points, you can't see unacceptable impacts. One of the things that we think about as unacceptable is the presence of things like the bacteria, Beggiatoa, or opportunistic polychaetes like capitalids. We get one species that forms this colony that you find right under the cage, and it's clearly associated with those highly enriched sediments. If we saw that outside the lease, we'd be really concerned. But then we found this second species. It's associated with enrichment, but it doesn't really like those highly enriched conditions. So we tend to see that further away from the farm. The presence of both those species can tell us quite a lot about the effect of farming in Macquarie Harbour. So we know that oxygen levels are low naturally in Macquarie Harbour. We established in 2013 that those oxygen levels have got lower. Now, in late 2016, the oxygen levels got to what I think would be fair to say critically low levels. I think it was acknowledged from everyone that there were some clear signs of stress. The system was talking back to us and telling us that it's not coping at the moment, and I think everyone's taken note of that. So our research moving forward is really about listening to the harbour, and in reality that's what we're doing. The amount that we're monitoring out in the harbour now has gone through the roof. At the start, the EPA were monitoring every 3 months. The industry were looking to expand. They had a monthly monitoring program. So that means going out there with a profiler once a month to each spot. And so that means you have to go and collect the data. So then industry started to go out daily. So the farm hands collect oxygen data every day. Now we've applied state-of-the-art technology, which is basically a string of sensors through the water column, no wires. They transmit the data acoustically to a central hub, and that data goes back via satellite. So we can look at this data real time from multiple spots in the harbour. So every minute we can look at what the oxygen's like anywhere in the harbour. You know, it's a world first, and it's been applied to Macquarie Harbour. And then the skate research that's been done in terms of the endangered Maugean skate, they're putting similar sensors that are measuring oxygen and measuring where they are in the water column, and that same data is being transmitted back. So that's really helping us understand where those skates are moving, how they're interacting with the low dissolved oxygen environment, and that data's all being transmitted via sound waves underwater. And later this year we're going to use one of CSIRO's autonomous vehicles, the Starbug, and we're going to have oxygen sensors on that, and it's basically automated, and you send that on missions around the harbour, and so it's going to go up and down to really spatially map where the oxygen is. Now in January this year, we went back out there and we completed another extensive survey of the harbour and all of the leases, and we saw that the fauna actually hadn't changed that much from October. So there were still quite low levels of fauna, and some places remained very depauperate. Oxygen levels had improved, and quite often what we see in summer is we can get those periods of reduced river flow, and we can get a bit of a recharge in from the ocean. So through summer and through into winter this year, we've actually seen better oxygen conditions than we did last year. We went back out in May, June and did another benthic survey, and that time we saw a really encouraging sign of recovery. We actually started to see the fauna come back. And up towards the mouth, that fauna had come back to levels that we saw before the decline. We were actually quite surprised that that recovery could happen so quickly. At the other end of the harbour where that decline was greatest, there's also been a recovery. It hasn't yet got back to what it was beforehand, but still encouraging signs. The big issues though in the harbour remain, and that is that despite that there's been some increase in oxygen, we've seen a retraction or a reduction in the amount of that bacteria around the leases, the oxygen levels in the midwaters in particular are still really, really low compared to what they are historically. History would suggest that we can grow salmon in the harbour sustainably. Salmon farming started in the 1980s in Macquarie Harbour. Now, the more recent deterioration that we've seen is a clear sign from the harbour that it can't cope with a certain biomass. The challenge now is about finding what is that biomass that is environmentally sustainable into the future. Yeah, look, Macquarie Harbour is a challenging environment, not just because of its ecosystem, but because of the politics and the tension surrounding it. So it's quite a challenging place to do science. But at the same time, it's really important that that science gets delivered nonetheless. And so our role is to deliver that science to the decision makers, to the industry, but most importantly, the community need to know about what's going on in that harbour, because it means everything to them. I mean, that is one of the most picturesque places in the world, and it's their backyard. Their livelihoods depend on it, but they're immensely proud of that place. You know, as a scientist, that gives you energy, and it's really easy to get over there and talk to them when you can see that passion. We can dwell on what's happened in the past and the decisions that were made, but it is what it is. We've got some real challenges, and we've got to make sure we work forward to restore the balance in that system.